Should be, right?
Yeah.
We're good. That's important. All right, so how is this different? So we have 16 grams of oxygen. Jackie's not here. So how is this different? Jose? See? What did you guys talk about? So we have 16 grams of oxygen. How many moles of water are produced? How is this different? What's that? I can't hear you. Don't worry about the people in the room. I know you weren't here, but Daisy, help him out in your group. What's different about that? And what are we starting with?
16 grams
of oxygen. So how is this different? How is this different than what we've done? Let's look at the last slide. So this one says we have 16 grams of oxygen. How many molecules of oxygen are produced? Now let's go to this one. If we have 16 grams of oxygen, how many moles of water are produced? Right, so Daisy, what's different about this? Yeah, right, so we're changing our elements or our molecules, right? We're changing them. So before we get to our first problem, I want you guys to think about something different. So let's go and get this, we have a new meaning for our equations here, a new meaning. So let's write this down real quick and I'm going to release you on a tough problem. So I want you to think of coefficients as moles of atoms and molecules. So here we have a reaction. Nitrogen plus hydrogen forms ammonia. I want you to think of coefficients as moles of atoms and molecules. So let's take a look at this reaction. H2 plus N2 is NH3. Is this reaction balanced? Take a look at that. Elvis, is this reaction balanced?
No.
Why not?
No, that's the reactants. On the right side, the N only has one. On the left side is two.
Good. So if you guys see on the right-hand side, there's only one nitrogen. So we have to balance this, right? We've done this before. So if we had a 2 in front of the NH3 and a 3 in front of the hydrogen, it's balanced. So I want you to think about those numbers just for a second. Those are moles. So how many moles of nitrogen do we have? Take a look at this. What's our coefficient, class? 2 or 1? 1. Right? 1. Because there's an invisible 1 here. So how many moles of nitrogen do we have? 1. How many moles of hydrogen do we have? 3. How many moles of ammonia? 2. Okay? So I want you to think about that before we go on to this next problem. So I want you just to write this reaction down. And this is the problem that I want you guys to think about. This is our inquiry. So if we have 16 grams of oxygen, how many moles of water are produced in the following reaction? So this is why we're in groups today. We're going to really pick each other's brains. 1. Because then it wouldn't be oxygen, it would be a 10. Okay, so this is what you're going to do. Figure out the problem, basically. Okay? Figure out the problem. And the group who wins, this is the trophy. We have to return it. Legion Genius hat, just for the day. You can even wear it. You know you want it. You know you want it. Okay, so this is your job. I'm going to give you about 10 minutes. You need to figure out this problem. When your group has an answer, I want you to raise your hand. I'm going to come around and check it. Okay? Do your best. Ready, set, go.
Is it set up the same way with the picket fence method?
Maybe. Yep. I would suggest starting with what's given and what's your picket fence.
Okay, yeah, I think we should start.
Your picket fence is.
So, is there 1 mole of oxygen? Oxygen.
No, isn't it 2 moles of oxygen because it's O2?
No, it's the coefficient. The coefficient is how many there is. Oxygen. How do we write that? 1 mole. And then you put cancel out the mole, you put 1 mole. Then you do 2 moles of H on top, or does that go on the bottom to cancel?
It has to go on the top to cancel out moles, doesn't it?
No,
No, cancel out.
If you have an answer, I have to see it in the picket fence from start to ending. Go ahead. You got an answer?
16 grams of oxygen.
All right. So what we started?
Water.
Oxygen. That's probably a good idea. What are you guys gonna do with that? Sprinkle hop. O2. Put in the picket fence, right? But where? And then where are we going?
Moles of water.
Moles of water. So that's a key there. Moles of water. So you guys don't have to make a jump here, right? Yeah. All right. No, that's a good question. That's a good question.
Just top first. Okay, 16 grams.
Get our papers wet.
Okay, 16 grams.
Start with what's
So we
given.
gotta,
Look with where we're going. Start with what's given. Look at where we're going. Look at what our notes that we just took.
Process finding grams and moles of particles.
Now we're in moles.
yeah, I think it's
Now we're in moles of O2. Where do we want to go to? Where do we want to go to? Moles of H2O. So we have to figure out something that's going to go take us from oxygen to water. Again, what is different about this problem than what we've done before? What else is given here? What have we been writing down that we haven't written down in quite a long while? Yes, okay, so think about that. What about?
So, but we
An idea?
Well, okay, so there's, we have a coefficient of 2, and we need H2.
or you multiply by 2.
Do we
First of
multiply?
all, start with what's given.
Divided.
You have to start with what's given, right? Because what if I give,
Because
let's say how much
we have
water is
16
in
grams.
What if I give you like,
would we go back to 6.02 then? Because now then we'd be in moles, but then how would we go to oxygen? I mean water.
We'd have to add in the H2.
an idea?